Okay, I said in the previous clip about coastal environments that a lot of the material in this early stage at least will be familiar to you if you've studied rivers or coasts at GCSE, and in fact will overlap from the Rivers Floods and Management Unit and this AS course as well. Coastal processes can be divided into two groups. Marine processes are ones that are to do with the sea, caused by the action of waves. I'll be looking at erosion and transportation in particular, but there are also subaerial processes that are to do with the work of the atmosphere, weather, I suppose, which could cause weathering, mass movement, and runoff, which brings eroded material into the coastal system, and as well just affects the shape of the cliffs and the shape of the beach. So those are the two processes that you need to be aware of. Start with marine processes. 4 types of erosion. These are all ones that you should be familiar with already. Hydraulic action is the action of waves as they crash against cliffs, compressing air into bedding plates and joints in the cliffs. And as the water retreats, as the wave pulls back out, the pressure is released, but there tends to be a kind of an explosive effect as it does so, which accumulated over 2 high tides a day and succession of storms over several hundred years will gradually weaken the cliffs until bits start to fall off. Corrosion, abrasion, 2 terms for the same thing, is when eroded material is picked up by waves and thrown back at cliffs and dragged across wave-cut platforms, leading to further erosion. Corrosion or solution, again 2 terms are basically the same thing, can happen several different ways. You can have chemicals in seawater which dissolve certain types of rock, particularly ones that are calcium-based. Limestone would be a very good example of this. You can also have certain types of rock that are porous, that is, that they will absorb water. If they absorb salt water, or if the rocks naturally contain salts themselves, if the water's absorbed at high tide, and then at low tide the rock dries out and the water evaporates, the salt can form crystals, and those crystals expand when they form, and obviously that puts the rock under stress. It can sort of break apart from within. That process is called hydration. That might be new to people. And the 4th process is attrition, which doesn't really affect the shape of the cliffs or the beach. It's more to do with the eroded material colliding with more eroded material and becoming more and more eroded. Freshly eroded material tends to be bigger and have much sharper edges. As it erodes, it will become smaller, smoother, and rounder. So it'll go from boulders to, say, stones, cobbles, pebbles, shingle, eventually into sand. Process of transportation by the action of the sea is another one that you should be aware of. Longshore drift. It happens where waves hit beaches at an angle. The direction of the waves will be determined by the prevailing wind direction. So if the prevailing wind hits a coast at an angle, then the dominant wave direction will follow that and also hit the coast at an angle. What it means is the swash phase of each wave will push material up the beach at an angle, whatever the angle is that the waves are arriving at. Gradually the wave will lose energy as a result of friction with the beach until gravity takes over, and that will then cause the backwash phase to kick in. Water will travel back out to sea down the direction of the shortest and steepest slope under the influence of gravity, normally at right angles to the coastline. So what you have is this diagonal movement of material up the beach, and then movement of that same material straight back down the beach at right angles to the coastline. Over the period of each successive wave and obviously successive high tides and low tides, what you have is this zigzag movement of material diagonally up the beach, straight back down, diagonally up the beach, straight back down, diagonally up, straight back down. The net effect of that, the overall effect of that, is referred to the diagram on the screen there. Longshore drift will carry material from right to left as we're looking at the screen. So, should all be revision up to this point: erosion and transportation. Subaerial processes include weathering, which is not the same as erosion. Weathering is where rock is broken down, but is left where it is. It's just weakened. Erosion is the process by which bits of weakened rock, or broken rock, are actually picked up and started to be transported. So they are subtly different. Weathering processes can be divided into three categories. This I think you'll have probably studied in science. Physical weathering, in areas where temperatures between day and night tend to be either just above or just below freezing, you can get frost shattering or freeze thaw weathering happening, which is where water freezes and expands in joints and bedding planes in rocks overnight. Then by day that water melts. That cycle repeated day after day after day, night after night after night, will obviously weaken rocks. In areas where temperatures get very, very hot during the day, desert areas particularly, you can have exfoliation weathering, onion skin weathering, or what's also called thermal expansion happening, where outer layers of rock that are exposed to the direct sunlight and the heat get warmer, expand, and peel away from the colder inner layers of the rock that don't get the sun's heat on them. Over time, that can cause those outer layers to gradually peel away, as I say, be weakened and fall off. You also have chemical weathering. The main type of chemical weathering is the process by which carbonic acid, which is carbon dioxide dissolved in rainwater in solution, acts to dissolve certain types of rock, particularly calcium-based rocks like limestone. That process is called carbonation. There is a little footnote to that, which I'll come back to in a second. But the third type of weathering is biological weathering. Again, a couple of different types. Some organisms, like seaweeds and certain shellfish, attach themselves to rock and weaken it. Also, you can have certain types of algae that, if they grow on rocks, release chemicals that can cause corrosion or solution to take place. I said there was a footnote to chemical weathering, which is simply to point out that it generally includes acid rain, but there is more than one type of acid rain. In fact, acid rain can be a mix of different types of acid. I'm not going to go through what's on screen in detail because you don't particularly need to know it, other than to just point out, obviously, that the use of fossil fuels in car exhausts and thermal power stations releases greenhouse gases that include not just carbon dioxide but sulfur dioxide and nitrous oxide. They can all react with oxygen in the air and dissolve in rainwater to produce different types of acid. So acid rain tends to be a mix of several different kinds, which will all attack different rocks in slightly different ways. The substantively new bit of what I'm going through here is what's called mass movement. And this is the bit I want to take some time to explain. The diagram on the screen categorizes different types of mass movement by slower ones are to the right of the box and faster ones to the left, but also processes that involve higher levels of moisture are up towards the top of the box, and ones that happen where it's a lot drier with less moisture down towards the bottom. First one I'm going to start with that's highlighted there is soil creep. That is a very, very slow process. We're talking probably less than a centimetre per year. It can happen three different ways. You can have raindrops hitting exposed soil or sand dunes, I suppose, which will just throw particles up, and as they fall, if they're on a slope, they will drop slightly further down the slope because of gravity. That can accumulate over time. The second process can cause soil particles to expand if they absorb water after particularly wet periods, which makes them more likely to fall downhill under gravity as the soil dries out. And a third one can be where water in soil freezes, which can push particles up towards the surface. As the ground then thaws out, those particles can fall down slightly downhill under the influence of gravity. Like I said, very, very slow process, but accumulated over a period of time, it does have an effect in terms of moving material and shaping the coastline. A similarly slow process, but one that involves much more water, is what's called solifluction. This occurs mainly in tundra areas, that is periglacial areas, areas around the edges of the poles, where soils are frozen for maybe 9 months of the year, but for the other 3 months, at least the top layer of soil, the water thaws out. What can happen is that can lead to the top layer of soil that actually has water as water, not frozen as ice. It can lead to it actually actively flowing over the top of the lower layers, which maybe are still frozen. Like I said, still a very, very slow process, but when you add more water in and when the layers down below are frozen, you can actually have the entire top layer very, very slowly flowing down the slope. Earth flows and mud flows, slightly quicker processes, but also involve a lot of water content. In fact, they can cause up to about, in some cases, in the region of about 10 miles of soil movement per year, mass movement per year. They particularly happen on steeper slopes, say between about 5 and 15 degrees, where the slopes have become heavily saturated after long periods of rainfall. Mud flows tend to happen where the material is finer and perhaps less consolidated, which causes them to flow more quickly. Earth flows tend to happen where it is coarser material and also material that is more well defined, well structured. That can just give it a little bit more resistance to mass movement to cause it to flow more slowly. But it's still worth considering the two together because they basically happen the same way. Slides and slumps are not actually that dissimilar, so I'm going to treat those two as a pair as well. Earth flows and mud flows are different to landslides and slumps in that mud flows and earth flows are much more chaotic. The material, when it does finally release and flow down the slope, will just be all mixed up. It won't retain any structure that it might have had. Slides and slumps are different in that a whole section of the cliff, the slope, will give way, and it will all move, but it will move as one mass and will actually tend to retain its overall internal structure. The difference is landslides tend to be more of a straight movement along a sort of a straighter line, whereas slumps tend to be more rotational. I'll put a diagram up to show rotational slumping in a little bit because it is relevant, I think, to the main case study of coastal erosion that we'll be studying. You may even be able to guess what that is. Two more types of mass movement. Rockfalls particularly occur where cliffs are undercut by the sea, especially on steeper slopes, more vertical slopes. Very simply, what happens is that the cliff is attacked until it can't support its own weight, and the rock disintegrates and falls off. There is a final process that's not shown on the diagram, but that is also worth mentioning, called runoff, which is where overland flow, whether it is a stream or at times of flood, just carries a certain amount of soil or silt or clay-sized particles with it. So you have effectively a very, very dilute layer of flowing soil running across the surface, which is a type of mass movement and can happen extremely quickly, obviously, because it happens at whatever speed the water is flowing at. I said I put a diagram up about rotational slumping. Particularly happens, two of the most famous areas, which you'll have almost certainly looked at least one of previously, are the Holderness coast of East Yorkshire and the North Norfolk coast, and the area around Haysborough. Very similar coastlines in that the coast is made of very soft, unconsolidated glacial till. As that becomes waterlogged, as it becomes saturated because of rainwater soaking into it, it becomes increasingly unable to support its own weight. Sections can give way, but they don't just collapse downwards, they will rotate downwards and outwards. Down at the bottom, you can sometimes have what's called a frontal lobe, LOBE, where the very most saturated material down at the bottom will actually flow. It'll probably look more like a mud flow, but everything above it will have slumped rotationally. And that's about it. I say about it because obviously the list of key terms on the board there is on the screen there is quite extensive, but these first 2 or 3 videos will involve a lot of keywords, and the bulk of the unit will then applying them to specific examples. If you want to follow up the research, coastal processes is the general term. Marine and subaerial processes are the 2 categories it can be split into. Weathering, erosion, transportation, mass movement, deposition will all fetch up additional material. Perhaps you may need to just specify coasts or coastal alongside those. And there's a photograph there of what rotational slumping actually looks like in real life, which some of you may even recognise as Mappleton on the Holderness coast. Some of you may be getting a little bit nostalgic for that particular